Okay, what I'd like to look at today is something called the Medical Subject Headings, or MESH headings, M-E-S-H. These are developed by the National Library of Medicine a number of years ago, and they're categories of information, a hierarchical listing of categories of information used in medicine. This is the 2003 listing. There are more recent listings, but for purposes of example, this is just fine. I'm required to say by NLM you should not use this for clinical purposes as it is out of date. All right, what we've got here, and this is the way the text file for MESH looks like, is that you have a description. At the very top here we see body regions, and we have a code, A01. They're separated from one another by a semicolon, which you can see perhaps in the middle there. I can highlight it. All right, so body regions, A01. Abdomen, A01.047. Abdomen is a body region. Abdominal cavity, A01.47.025. Abdominal cavity, not surprisingly, is in the abdomen. The peritoneum, A01.047.025.600. The peritoneum is in the abdominal cavity, which is in the abdomen, which is a body region, and so forth. And we go down the list here. What I would like to do is to turn this into a tree, and it seems like it should be easy to do. In order to make it a tree, I would have to write a bunch of assignment statements creating a mesh tree. Now, what would they look like? They would look like this. I did it earlier. And let's have it roll it up on the screen here. These would be, so if I had some global array called mesh, all right, and I wanted to index it by the codes associated with each of the descriptors, A01 would be body regions, and that would be the assignment statement. Set up arrow mesh sub A01 equal to body regions. Abdomen would be A01, 047. Abdominal cavity, and you can say there's 3 indices. Peritoneum, it's got 4 indices, and so forth. So I would like to be able to build something like this, which I could then execute. All right? And once I execute it, I would have a tree. How would I do that? Well, I have 2 copies. The one that's in the book is slightly different than this. This is a bit shorter, but it works out to the same thing. All right. First of all, get rid of any earlier versions of the global array mesh. Secondly, open the file that's got all of those codes in it. The abdominal cavity or body region semicolon A01. Okay, that file. That's mtrees 2003.txt. And old in my version of mumps means it exists and I'm about to read it in. And I'm opening it as unit number 1. Now, the open statement varies a great deal depending upon the implementation. So you got to check your own system. If $test comes back as false, if not $test, then I say we can't find the file, and I quit. We halt. All right, so the file's there. It's ready to go. So I have a for loop. Notice there's 2 blanks here. The for loop with just do forever, basically, forever. It'll run until the quit executes. All right, use unit number 1 and read the line, read A. Probably could describe it more. It's better than just A, but mine's an interpreter, so you want to use short codes as possible. Reading a line. Okay, so we read in a line A. We will quit if $test is false. So if $test is false, not $test will be true, and the quit will execute. The quit will terminate the for. Quit on a for line terminates the for. So if I have no more input, if I run out of input, $test will be false, not $test will be true, and we quit the loop. Otherwise, and again, notice there's 2 blanks after the quit, because quit doesn't have an argument. The postconditional here is not an argument. It's postconditional. Quit has no, in this case, has no argument. So there's going to be 2 blanks. I execute a do. The do will invoke the block. You can see the block starts here and it extends all the way down through this line here. Oh, wait a minute, it goes further. It's all the way down to here. Okay, so this is the block that's being done by this do. All right, first of all, we want to extract the pieces of the input line. The first, delimited by the semicolon. The first piece will be the verbal description. The second piece will be the set of codes. All right, so we set key equal to the first piece, delimited by a semicolon. That's the text description portion. And the second part, which are the codes, is the second piece, obviously. All right. The key part, that's fine. That's just going to be a text description. What I need to do is separate out the code portion, because the code portion consists of one or more codes, A01 dot, whatever the next one was, dot, we want to pull those out separated by dots. All right. So for I, going from 1 by 1, no upper limit, I set a local array, x, equal x indexed by I, x sub I, as we say, equal to the piece of code delimited by a dot represented by I. So it's going to be the first piece, second piece, third piece, fourth piece. I don't know how deep they go. I think they get down around 8. I'm not sure. The I, every time it increments, of course, for the 4 here, is going to, get me to the next piece. So it's first piece, second piece, third piece, delimited by a dot. When I run out of pieces, when the piece comes back and gives me an empty string, so if x sub I is equal to empty, we're done. We have looked at all the pieces. The first thing we do after exiting is we want to decrement I, because I is 1 too high. I would represent the piece that's empty. So we decrement I. And we switch back to unit number 5, because I will be writing it out eventually. Now we're going to begin to set up a global array reference text, a string containing a global array reference. And we're going to say set z, again another short letter, equal to the string up arrow mesh open parentheses. That's just a string. Now what we're going to do is concatenate onto this string at the end successive index values. So it'll be A01, comma, whatever, comma, whatever, comma, whatever. Okay, that's what we do that down here. For I goes from 1 by 1 to I minus, j goes from 1 by 1 to I minus 1. Why I minus 1? Because the last one is special. The last one we're going to slap a closed parentheses onto it. So we only want to do the ones up to but not including the last code. And what I'm doing, it looks like somebody sat on the typewriter, but it really isn't that difficult. As I set z equal to what's already in z, concatenated with, this thing here works out to be a quote. Double quote, remember, is interpreted, 2 double quotes right next to one another are interpreted as being a single quote, which I have to have, since that's a string, I have to have it within quotes. So this whole thing here, when it gets concatenated onto the end of z, will just be a double quote. All right, then I concatenate the actual code, x sub j, where j goes 1, 2, 3, 4, whatever, up through but not including the last. And then I put, there's a string here. This is string here. It begins here, ends here. This part right here is a single instance of a double quote. Again, 2 adjacent double quotes. It's a single quote. It's a single instance of a double quote. All right, and a comma. So basically what I've done on this line, as I've said, z is equal to z concatenated with quote, the value of one of the codes, quote, comma. That was appended onto z. All right. The last one here is we use the index value I, because that's the last code that actually worked, that actually is there. We set z, here we're going to add some stuff to it. We set z equal to quote set concatenate z. So all of this mesh stuff is put onto a line that is put into a string that begins with the word set blank. So z concatenated with a single double quote, the value of the last code from the original string, a close double quote, and a close parenthesis. The character equal sign, a single instance of a double quote, the value of the key, and again a single instance of a double quote. what does this look like? Well, it's going to look like this line here, more or less, for the first one anyway, or second one, I think it is. What Z will look like this bit right here. Well, if I can color it in without the thing going crazy. That's what it'll be in. That's an example of what's in Z. All right. So it'll look like a line of mumps, but it's just a string. It's not actually a line of mumps. It's just a string. Okay. Then I write out Z so I can see it on the screen. But then I execute Z. I execute the string in Z, and since the string in Z is syntactically a valid line of mumps, it runs. And I actually do put into the database an instance of one of the tree elements. And when I'm done, I close unit number 1. Could have closed it earlier, as a matter of fact. I switched to unit number 5 because actually the last thing I did was probably read. Was read from the input, so you're not on unit number 5. I write out done, and I halt. Does it work? Well, I think it does. And the way I will do it, I'll do it this way. Dot 1, and I'll run it into more. Okay, more is the will show me a page at a time, so it won't all flash by. It's a Linux command. Okay, hit enter. And what we're seeing is that write statement where it writes out the value that was in Z. And you can see they get longer. Like abdominal cavity, there's the codes. There's peritoneum. There's Douglas pouch, which is part of the peritoneum, and so forth. And how many deep here we got? 1, 2, 3, 4, 5, 6 levels deep. Anything look like it's longer than that? I don't know. There's quite a lot of them. Oh yeah, this looks like it's much lower. 1, 2, 3, 4, 5, 6, 7 levels deep. So we're building a tree. Now internally, we've got a tree with these codes, and you can navigate it, and you can print it out, which we'll do in a later video. All right. I'll let them flash by. All right. Very good.